Hello, welcome to Knowledge of Physics. In this video, I will show you the projectile motion by the animation. And before showing you the animation of projectile motion, I want to explain you some theories of projectile motion. A projectile is nothing but the object which is projected with the initial velocity u and making certain angle theta with the ground, and the projectile returns to the same level of the ground after the time t, capital T, which is also called time of flight for the projectile, and it is given by 2 times the initial velocity or the velocity of projection u times sine theta divided by g. G is the acceleration due to gravity and theta is the angle of projection. The projectile goes up to the height h, maximum height h, which is given by h is equal to u square times sine square theta by 2 times g. As I have already told you, u is initial velocity and theta is angle of projection and g is acceleration due to gravity, and h is the maximum height that the projectile attains before it falls down to the ground. And r is range, horizontal range, and it is given by u square times sine twice theta by g. Horizontal range is the distance from the point of projection to the point at which the projectile falls on the ground. So both h, r and t depends on u and theta, and the horizontal range is maximum when theta is equal to 45 degree, because when theta is 45 degree the value of sine twice theta becomes 1 and the r is equal to u square by g. It is because value of sine theta varies from -1 to +1. So for other angles the value of twice 2 sine theta becomes less than 1, but if the theta is 45 degree, or if the projectile or the body is projected with the angle of 45 degree with the ground, then the body reaches the maximum distance far from the point of projection.
The projectile follows the path as you can see on the screen, and it is almost half oval shaped. The equation of this shape, or the equation of trajectory of projectile, is given by y is equal to x times tan theta minus g whole divided by 2 times u square cos square theta.
So this is the basic theory of projectile motion, and let's move on to the animation. I have an application installed on my device, which you can also download on your device, for example the iOS device or Android device from App Store or Play Store, by searching on the search bar the projectile. So here this switch is for variation of angle, and this is for velocity, and this is for height, and this depart and pause option is for the for playing an animation. Okay, and here the body of blue color is the projectile or the body to be projected, and you can also see here position initial, x is equal to 0 meter, y is equal to 0 meter, this is initial condition, and final position is what? Final position means x is equal to what, y is equal to what, y max is equal to what. Okay, so to start the simulation, let me first click on this pause depart option, and let me show you how it acts. So see, the body has been projected. Okay, for this you can see here, I cannot zoom it. So in small words you can see angle DTIR is 70 degree, and mass is 1 kg, and velocity, initial velocity bt is initial is equal to 9 meter per second. This means velocity of projection is 9 meter per second, and the projectile has the mass of 1 kg, and it is projected with an angle 70 degree to the ground, and the final position is x is equal to 5.919 meter, y is 0, okay, and y max is 3.6 meter. So maximum height that the projectile attained is 3.6 meter. Now let me vary the mass of the projection for the same angle. So now let it be 1.3 kg. So let me see the nature of the projection. If the mass is increased, then okay, there is no difference in the nature of the projectile motion. So you see 3.261 is the maximum height, and x is equal to 5.22 meter. So let me decrease it little bit. So decrease the mass, and it is now 0.15 kg. If I play again, so when I decrease the mass of the projectile, then see the height it attains is lower than the before, and the range it reaches is also less than that of before. So this shows that if the mass of the projectile is the projectile having lesser mass attains less height and less horizontal range than the projectile having higher mass. If I increase the mass again, it is now 2 kgs, and let me play the animation. See, with the increase of mass, the height it attains, the projectile attains, is increased again, and the horizontal range also increases. Now let me vary. Let me put the mass as 1 kg. Okay, and let me vary the velocity. Okay, this is velocity. This shows the variation of velocity. You can see now it is 9 meter per second. If I decrease it to 5 or 6 meter per second, then let me play the animation. See, with the decrease in velocity, the height that the projectile attains is decrease, because h is equal to uv square sin square divided by 2g. So if u is less, then h is also less. Also, if I decrease it more and play the animation again, the height is again very small. Let me increase it to 9 meter per second, then play the animation and see the height the projectile attains is again higher than the height when the projectile is velocity of projection was less. So in this way the velocity of projection varies with the velocity of projection causes the height, maximum height the projectile attains to decrease, and the range as well. Now let me keep the velocity as 9 meter per second and mass as 1 kg, and let me vary now the angle of projection. So this is for angle of projection. Actually this is not angle of projection, it is height of projection. So height of projection means height from the ground. So if I increase little bit this much from ground, then let me play the animation what it shows. See, okay. This graph shows the projectile motion when it is projected from the ground. And now let me play it again, and this graph shows the projectile motion when it is projected from above the some height from the ground. So in this way you can understand the projectile motion, how it varies with how the graph varies with varying mass and varying velocity of projection, and how its nature looks like when the body is projected from some height, okay, above the ground. So you can download this app on your device and play with the animation, and it will help you to understand the projectile motion even more precisely and more clearly. Thank you so much for watching this video. We will see you in next video. Thank you so much.